Good afternoon, ladies and gentlemen. Today we will discuss how to build a water rocket. First of all, the physical principles of the water rocket. You take a rocket, you put there some water, then with the tube you put there additional pressure, and then you open the entrance here, and the water goes out. It goes out very fast in this direction, and the bottle goes up that direction. So that's the physics, the momentum conservation law. How do we do it in practice? We take a bottle of something that can hold high pressure, which is, for example, Sprite, Cola, Fanta, whatever. Then we take the cork, I'm not sure how it's in English, the device that you put in the bottles, something like this. Yeah? You take this thing and you put it into the bottle of the cola. And you also take the tube and put it inside. So it goes through. Here you put a pump and you push the air inside, it goes here, makes additional pressure, and then at a certain moment the friction here is not capable to hold the cork, and it throws this direction, water goes here, and the rocket goes up. How to make it practical? Now some engineering skill. What do we need? Well, we need first of all the bottle, this we know. Never take the bottle from the normal water. Normal water is not supposed to keep pressure. So where the normal bottle from the normal water, if it explodes in the hands, it's not fun at all. I tell it from experience. Now, the cork. Then we take a tube. The cheapest tube, it's maybe like 50 cents per meter. The inner diameter of the tube is 4 millimeters, and the outer diameter of this tube is 6 millimeters. And then we take the bore, the drill, whatever it's called, with the diameter of 6 millimeters. Why 6 millimeters? Because this thing is also 6 millimeters. So if we want to drill a hole, it should have pretty much the same diameter. If it doesn't go through, if it doesn't go easily through the cork, you just with a drill machine make the hole a little bit bigger, but not too much. Otherwise you would need to use some additional device for the isolation. And anyway, here is the Plasticine device that kids are using to make some cats, dogs, castles, yeah? But not the one that that dries at the air, the one that remains flexible at all the times, yeah? Or any other thing. Even the chewing gum will be fine. Now, what do? We take the bore machine, we put the hole in, and we make a hole. Important, at least use the gloves, or better use some kind of tongue to hold this device and make a hole. So be careful with this. If you don't have experience, be very careful with this. Now, when the hole is done, what you do next? Next you take the very sharp it's called knife. Well, you take the very sharp knife and you start to cut it. Why do we need to cut it? Because if you take the normal cork and you look to the diameter of the bottle, it doesn't fit simply. So we cut it onto the conus and it will fit then inside. Be careful when you cut it, cut it many times, because if you cut it maybe like 1, 2, 3, again there are going to be some problems with the isolation, and the water or air will escape here. This is not what we want. Here, by the way, approximately the amount of material that I have cut from this cork. Next, well, actually probably the time for the demonstration. Let's get some music, by the way. The tube, we put it inside. If it goes through, it goes through. We put the isolation around, otherwise the air will escape here through. In the next modification, that problem is more or less solved. So, hold, put this device and the pump. That's our beautiful pump. Ta-da! Let's start. I'm not sure if it will go because yeah, yes. Approximately 2 meters. Hold on, I'll keep it. Now, what can we improve in the system? The experiment has been done with the air. If you would do it with the water, you will notice here you have put water, and here you put a lot of bubbles, goes out. But you don't want those bubbles, the water goes back. So what you do, you put some kind of valve. The valve you can get out of the normal rubber tube from the bicycle. The valve looks like this, but there are different types. Take the one the smallest. Then it fits more or less into the shank, into this tube. But when you try to fit it, it doesn't always goes in. Look, they have rated pretty much the same diameter. So what do? We can make it a little bit bigger. You see, it's slightly bigger than that one. How do we do it? We take a hair dryer and we warm it up. When it becomes warm, it becomes elastic. But and then we can make the hole a bit bigger with the scissors, like this, or warm up this thing. Not do it with the hands, otherwise it can burn. And when those things are hot together, you can put them much more easier. And you shouldn't put them too far. That's normally sufficient. And how it should go? It should go this direction. Yeah. Here's the valve, the air goes here, so we can get the whole thing through. And voila! Here we put a bit of isolation. Blip. And we're ready to go. This thing should hold better. Ready to go. What else can we modify? We can put a little bit more isolation here. Maybe make put with the isolation tape. Maybe it will hold better. I don't know. Just try it. And I'll make this conus a bit longer, because for the moment I can put it only to the half. You see, it starts to deform. So you can easily cut until here. That's it. Then yeah, later somewhere in the other movies there are gonna be the real experiment. Good luck and see you. Ciao.